how to evaluate logs. We've talked a lot about exponents and exponential functions this week, and a logarithm is the mathematical operation that undoes an exponent. Okay, so just like square root undoes a square, and adding undoes subtraction, and vice versa. Every operation that we've done in math has an opposite. Well, taking a log of something is the same thing as undoing an exponent. So it kind of goes in this little circular pattern right here. It says log of base b of y equals x. Now this little number in the bottom is our base. The number after the equal sign is your exponent. My Algebra 2 teacher would say a logarithm is an exponent. So that means whatever the log stuff equals, this part is the exponent. It does. So logarithm equals an exponent. So your base is going to be, it's easy to pick out the base because it's always the number on the bottom. This is your exponent, and this is the answer. So for example, what we're going to do is rewrite logs in exponential form. So they're going to give us a logarithmic form of a function, and we are going to convert it to an exponential. So the first one says log base 2 of 8 equals 3. So remember, it's kind of like you start with a base and you go into a circle. So your base is 2. Your exponent is what? The one that comes after the equal sign. So 3 equals 8. Is that true? Is 2 to the third power equal 8? Yes. Also, remember that blue sheet we got a while back? That might come in handy. Okay? That blue sheet might come in handy. So this is just rewriting it in exponential form. So this is in logarithmic form because it says the word log. Okay? So you start with the base. Your base is the bottom number, still the bottom number. A number after the equal sign is your exponent. And then you set that equal to the very last term. So it's like you go in a circle. Right here. It's like you go in a circle like that. Does that make sense?
Yeah.
Okay. All right, so the next one. Log base 4 of 1 equals 0.
So it's really 4 to the first power.
Nope.
Oh, the 0.
Yeah, you do this, and then back to this. So 4 to the 0 power equals 1. So you do like this. Woo! Does that make sense?
Julie Willis, Mary Grace Wilson, come to the office. We're getting ready to call and report you missing.
Okay. All right. So, is that true? 4 to the 0 power, is that equal 1? It is. Oh, well. All right. This one says log to the base 12 of 12 equals 1. So how do I write that in exponent form? 12 to the first power equals 12. That's true, isn't it? It goes like this. Does the loop help y'all?
Yeah.
Okay.
Yes, ma'am.
The loop help you? Okay.
How do you calculate it? You can't. They just form right now. We can't type.
I'm giving you a dirty look. You ain't typing in your calculator right now. We're not evaluating it. We're rewriting it. That's what. You're just rewriting it in exponential.
Kenny Brown, Joshua Mayfield, report to the guidance office, please.
No. All right.
Uh-oh.
All right, y'all help me write this one.
1.5.
That's not 1.5. It's a 4.
I mean, one power
To the
negative 1 power
equals 4. Do your loop. Okay, and that's true because 1 to the negative 1 and 4 to the negative 1, we flip them, and that's going to be 4 over 1, which is 4. Exponent rules. Negative exponents go to the other part of the fraction. All right. Do what? I do parentheses because you're raising the whole fraction to the negative 1 power, not just the 1. All right, I want you guys to try these on your own, on your paper. Convert these to logarithmic or exponential from logarithmic. Rewrite those in exponential, please. Do your loop if you need to. You just rewrite. That's all you're doing. And when you rewrite it, you get a true statement. So. All right. So what did y'all get for the first one? 3 to the 4th power equals 81. Raise your hand if you got that one. Good. So what'd you get for the second one? 1/2. Uh-oh. Why I put a negative? Miss Isabel not getting it right.
1/2
to the negative 5, equals 32. Did y'all get that one?
Yeah.
Can we do that all day long, right?
Yeah.
Do your little loop, and there you go. All right, so now we got to actually work something out with them. This says evaluate. So if something says evaluate, that means work it out. Yeah. So this one I want you to find log base 4 of 64. So what that means is 4 to what power, because they don't have it equal to anything, equals 64. So that means in exponential form, 4 to the x power equals 64. And this is where your blue sheet might come in handy.
64 divided by 4, right?
Nope. Nope.
Do that.
4 to what power equals 64? 4 what? 3rd power. So x equals 3. Blue sheet. Look for the ones that look for 4s and find a 4 to what power equals 64.
Where did you find that out on blue sheet?
You look for 4s.
4.
There it is up there.
Yeah.
4 to the 4th is that. So it's not 4. So it's smaller than that. So it's this one. All right. So let's do another one.
Yeah.
Log base 2 of 32. What does that mean in exponential form? 2 to what power equals 32? And I think that's on your blue sheet as well. Yeah, we did it a while ago. Yeah, and that's a common one, 2 to the 5th power, right? So
if you don't have the sheet, how do you find it?
You need to work with your numbers.
Yep.
Work with your numbers. Well, I'll show you how to do your calculator. Make sure I can do my calculator.
Yeah, I done got it right. 14. Oh, I didn't do it. I should have that.
No, I got it. Hang on.
It's gotta have a root problem.
No. Okay. All right. So in your calculator, let me get mine turned on. I know it's not it's not. You can't use the button because this has a different base. The one on the button is a log base 10. And this one had a base of 2. Hang on. So, turn it on. You hit the math button that's under the green alpha button. Arrow up instead of down.
Oh, man.
And I don't have it.
Hold on, what y'all need for now?
Well, crap. These calculators don't have it. 83s don't have it. 83s don't have it. 84s do. Yep, it does. So you're going to have to use your blue sheet. You use your blue sheet. And I don't think on homework that I gave you anything too difficult on that at all. I'm pretty sure I didn't. Pretty sure. I'm pretty sure I didn't write down problems for y'all to do yet. So I'm pretty sure I won't pick hard ones. Okay? Okay. We are about to use our calculator to approximate in just a little bit. Let's talk about common logarithms. And that's what your calculator will do. Because there's a button. The common logarithm is log base 10. Now what your calculator says for log base 10 is just log of x. So your calculator log button is just log of base 10. So that button beside the 7 that says log is base 10 automatically. So your calculator automatically does base 10. A base of 10. Now, we talked about the number e yesterday, didn't we? And so to take a logarithm of e, we call that the natural log. E is the natural one. I'm trying to spell logarithm. Logarithm. So log of base e is called the natural log, so we call it ln. So that ln that's below the log button, that's what you use when your base is e. Okay, so if you use base 10, you're going to use the log button. When you do base e, you're going to do the ln button. Okay? That's called the natural log. So log is base 10, natural log is base e. All right, so let's do some in our calculator. This is example G, correct? So we're going to do log of 8. So that's automatically base 10 because it doesn't give you a base. If it don't tell you a base, it's assuming it's base 10. You hit log and you hit 8. I don't even think you have to do that. I'm going to test it. I think you just hit enter. It's correct. It is. And then, no, all we have to do is round that to about 4 decimal places. And I'm going to use approximately instead of an equal sign because we're rounding. 0.9031. And you can check it. If you take 10 and raise it to this power, you should get close to 8. Now, I'll say it's approximately because it's going to be 8 point something, or it might be 7.99 something. Okay? But you can check it by doing 10 to this power should be something close to 8. Okay? So let's do a natural log. ln of 0.3. So y'all type that in and see what you get. ln of 0.3. 2040?
Yeah, 2040.
Negative 1.204. Yeah, I put squiggles. We squiggle because we're approximating. So what's my base for this one? E. We practiced doing E yesterday, didn't we? The second ln. So if we hit second ln, I'm going to do it on my here so y'all can see it, make sure. Second ln to get you the E to the negative 1.2040. I forgot my 4. Close parentheses. Hit enter. It should be something close to 0.3. And 0.29999 is really close to 0.3. It's not exact because we rounded our number. Right?
LN is the opposite of E.
Yes, it's the mathematical
And
inverse operation.
Logarithm is the opposite of exponent.
Is the opposite of raising something to a power. Yes. Good stuff. All right. Then we get to have fun with logarithm properties. So now we're going to learn about logarithm properties. Mm-hmm. Not right now. There's tissues right there. Step outside if you need to. All right, properties of logarithms. Logarithms, we can use them to cancel out things with exponents. So if we take log of a base and then use that base to an x power or whatever power, if I take the log of a base of that same base, those two cancel out and the answer is the exponent. So if the base and this number are the same, those cancel out and the answer is whatever is up here. Likewise, if I have a base to the log power of the same base of x, the base with the log of that base cancel out and the answer is the exponent. Yeah. So if I take the logarithm of this base of that base, they cancel out. That's how you cancel it. That's how it's a mathematical inverse operation. Logarithms undo exponents. Exponents undo logarithms. Okay? So all this will cancel out, leave you with x. All this will cancel out if it's written this way and leave you with the x. Well, you've never seen it before. So this is example I. So if I have 3 to the log base 3 power of xy, something cancels out. What cancels out? Log base 3 of 3, right? And the answer is xy. And that's how you simplify that. So anything that's the same base as what you're raising to a power, the bases are the same, they cancel out, including the word log. Okay? It leaves you with whatever's in the exponent. So, let's do example, this is example H. This one's a natural log. I'm going backwards on the alphabet, I guess. You're right. So the natural log cancels out an E, right? Because the natural log is a log of base E. So anytime you take the natural log of an E, those cancel out. And that answer is just 5x. Or that simplifies to 5x. Likewise, if you take E and raise it to the natural log power of, let's do x to the 4th. The E and the natural log cancel out. So same basis for logarithms have to cancel out. E and natural log has to cancel out. And what's left over that I didn't cancel out on K? X to the 4th power. Yeah, ln and E cancel out. Very good. Okay. So, this is the only thing that's really tricky about this. IJKL. Now, this looks like nothing cancels out. It does. But more importantly, to help us out here, I need this base to match this base. So 27 equals 3 to what power? What power? The third.
Yeah.
So I can rewrite 27 as 3 to the third power. So this is the same thing. Log base 3 of 3 to the third power to the x power. So all I did was change 27 to 3 to the third power. And so what does that log base 3 of 3 do? Cancel out. So that cancels out the base, the two bases, and the word log. So the x is not 3 to the x, because remember, if we take power, we multiply them. Now listen, if you take a power of a power, you multiply them, so that equals 3x. Does that make sense? Y'all, I know this is like a foreign language. Logarithms is the first time in your whole life you've seen logarithms. So that means it's going to take us a little bit of practice getting used to them, to be good at them. So we're going to start them. We're starting them today. We're going to continue with them into next week. The last thing we're going to do today probably is find inverses. Well, we got two more things to do. So the next thing we want to do is find the inverse of a logarithmic function. Do y'all remember? I forget what chapter it was. It's not been too far back. That if we wanted to find the inverse of a function, we swap the x and the y and solve for y. Y'all remember that?
5.
I think it was chapter 5. We'd swap x and y, and then we'd solve for y. Well, you're going to do the same thing when you have exponential functions. JKLM. I think I'm probably going to run out of room, so let me get some space here. So we want to take y to equal 6 to the x power and find the inverse of that function. So the first thing we want to do is swap our x and y. Anytime you want to find the inverse of a function, that's your first step, is to swap your x and y. So now my equation says x equals 6 to the y power. So I swap places with my x and y. And then after we swap our x and y, our last step is to solve it for y. So find the inverse of a function, you swap your x and y, and then you solve it for y. Well, it's kind of hard to solve for y when it's stuck up in an exponent. Okay? Can't really solve for it when it's really in an exponent. So what we do to get it to where it's not an exponent anymore is we take a logarithm. Now, what's the base for the exponent? 6. So when we take our logarithm, we need to do a base 6. So I'm going to take log base 6 on both sides. Because remember, for an equation, what you do to one side, you got to do to the other side. So put a log base 6 on both sides. And now guess what happens right here? That cancels out. So the answer, I'm going to come over here because I'm out of space. Log base 6 of x equals y. Because everything over here canceled out except for the y. Right? And my job was to solve it for y. Is y by itself? Yep. That's my answer. Now, it's not going to be a pretty little answer like 15 or -2 because it's a function. Okay, it's a function. It's a graph. It needs x's and y's in it. Variables. Okay, so this is my answer. So let's do some more of these. Which one do I want to do, though? Okay, let's do this one. So let's do one like this, a little more complicated. How are we going to get good at these, y'all?
Practice.
Practice it to the best of our abilities. All right. So I want to find the inverse of this logarithmic function. What's the first thing you should do if you're finding? Swap your x and y. If y'all can't do anything on the inverse, you can at least swap your x and y for me, can't you? Ain't none of us that lazy. You put the x over here where the y was. Yeah.
Not give out thinking. I thought you were gonna put the whole 5.
All right. But my y, we gotta get y by itself, but it's stuck up in an exponent. So what undoes an exponent? What?
And log.
The logarithm. So if I want to get rid of something in the exponent, I have to take a logarithm of both sides. Now, what's the base?
3.
3. So I need to use log base 3 on both sides. So log base 3 over here, and a log base 3 over here. What you do to one side of an equal sign, you have to do to the other. Now something cancels out. What cancels out?
The log. 3 logs.
Yeah, my log base 3 and my 3's, right? So then I have log base 3 of x equals 5y minus 4. Now y'all.
Add a 4 to the other side.
So now we're just simplifying this side to get it to just y, and we do the same thing as we've done in Algebra 1, and the same thing we did in junior high to get y by itself. Okay? Add the 4 to both sides. Those are not like terms, obviously. So log base 3 of x plus 4 equals 5y.
How do you divide the log?
You just make it a fraction. So you just put everything over 5. Hang on. I'll go back over it. Okay, so are you up here with me? So ignore this side for a second. I'm looking at this side. If I want to get y by itself, I got to move the 4, so I add it to both sides. So there's that. And then I'll have 5y over here. So to divide by the 5 to get rid of the 5, and I'll just stick it down there. And you're just going to leave it like a fraction. As long as y is by itself, you're good. So this is your answer. So these are not going to be little pretty answers. As long as you get y, you get to swap your x and y, and then solve for y, you're good. Let's try one. Let's do one we have to do the other way, which is exponentiate. Isn't that a fun word? Y'all say that word.
Exponentiate.
Exponentiate, okay? This is example O. Yeah, that's a good word too. Y equals log base 5 of x minus 7. Now this is backwards. So a while ago they were putting our variables in an exponent. Now we're doing logarithms. Okay? So first I need to do what if I'm finding the inverse though? Swap the
X and Y.
Swap your x and y. First thing you do is rewrite it.
X equals log to the 5th. Y minus 6.
Parentheses y minus 7. Well, I can't do anything with y because it's stuck in a logarithm.
Yeah.
So, okay, I've already got a logarithm though. What's the opposite of a logarithm? An exponent. So you're going to exponentiate, right? Exponentiate. Isn't that a fun big word? So if they give you logs, you exponentiate to cancel out. If they give you exponents, you do logarithms to cancel out. Okay? They're opposites of each other. They're inverses. So what base do I need to cancel out though?
The 5th.
A 5, right? So you're going to say 5 to the x power, because you got to raise both sides with the base of 5. What you do to one side, you got to do the other. So all of this is in the exponent. Y'all see that? Mine is just scrunched up really ugly. Okay? So the 5 log base 5 cancels out. Whoops. So it's 5 to the x equals y minus 7.
Add Y.
You don't add y. And then you add 7 and you're done. And so the answer is 5 to the x power plus 7 equals y. Don't y'all feel so smart doing this stuff? You should.
This is like something It's like something off the TCAP since I couldn't do.
Exactly. So, if you want to get rid of a log, you put it in an exponent. If you want to get rid of something in an exponent, you take a logarithm. Yeah.
It's fine.
Let's do one more, and then I think we're gonna call it a day.
Yeah.
We're gonna do some more log practice next week. We haven't done a natural log since we've been doing this. A natural log. Natural log is log base what?
The LN.
Ln, which is logarithm of base what?
10.
Nope. E. E. Natural log is log base E. Okay. Oh my gosh. Okay. So base E means what base do we need to? Okay, first we gotta make it an inverse, right?
So that means we got to change the X and the Y.
Change your X and your Y. Swap them up.
X equals L E equals Y plus 3.
Very good. So, if Ln is log base E, so the base I need for my exponents is what? E. Some students say you're going to E both sides, but you're going to exponentiate both sides. Okay? People say E both sides, but you're going to exponentiate both sides. So you're going to say base E on both sides, E to the X power equals E to the Ln power of Y plus 3.
Cancel out.
Yep.
EX equals Y plus 3 minus 3.
Hey, yeah,
Minus 3 equals Y.
you get it. So the E and the natural log cancel out. That's why you did that. And then we get Y by itself by doing what to both sides?
Add 3. Subtract
Yeah.
3, I meant.
Subtract 3. So the answer is E to the X power minus 3 equals Y. So that's how you find the inverse of a logarithmic function. All right. I'm not going to give you many that you have to. I do want you to rewrite them because those are easy. Let's go ahead and put our practice. I'm going to stop recording for today. Goodbye, YouTube.